Okay. Hello, 9G. For some of you who are not able to join my discussion on how to work with scaffold number 3, I hope that this video can help you, okay, as you finish or accomplish the tasks. So I want you to read the situation, and then I am focusing on how the calculations. Okay, so be reminded that you are given a model. You're asked to analyze the model. Okay, then on here you get to see points. Point A, B, C, D, E, F, G, and then you need also the data presented in the y-axis. Okay. Now, please take note. So, uh, where can you find point A? What's the height of point A, point E, point G, or F? You have a reference there, so you use this. Now, please take note that the starting point is at point A, where the vertical drop of 70 meters above the ground starts. Then in every point A, B, C, D, E, F, G, H, okay, you're going to calculate the following: kinetic energy, potential energy, velocity, and momentum. Assuming that the mass of the roller coaster wagon is 512 kilograms. 512 kilograms. Take note. So, formulas are also presented in the file. Just use this, okay, as your guide. So, given, we have this. Now, let's calculate. So, for points, for A, we have height meters. Where can we find, or what is the height of point A? Right, to take a look at here, that is 70 meters. Okay, then we will place it or fill in the part, that part. So we have 70, wait for a minute. So we have 70 meters. Oops. Now you are asked to solve for the, oh, what are meters? Now what's the potential energy? Okay, as what was discussed about energy, you've learned that PE is equal to mgh. Then we have our mass, which is 512 kilogram. We multiply it by 9.8 meter per second squared times 70 meters is equal to 351 232 joules. Okay. Then, do we have kinetic energy? Please take note that that's the starting point. So, our velocity here is 0. Therefore, kinetic energy, as basing from your reference, is mv squared over 2. Then, since our velocity is 0, that's the starting point. Therefore, our kinetic energy is also 0 joule. Now, how do we get the total energy? E total is equal to kinetic energy plus potential energy. Thus, we have the E total given 0 joule plus 351, 232 joules. Okay, so E total is equal to 351,232 joules. Now, our velocity is what? Since our kinetic energy is 0, we able to calculate the velocity, which is square root, right, of 2 kinetic energy over m. Okay? Since kinetic energy is 0, we will have a 0 here. Then in the momentum part, okay, so mass times the velocity, since the velocity is 0, therefore momentum is also 0. Okay, kilogram meter per second. Now, that's the first point. I will do the second points, and for the rest of the points, it's you're going to finish that. Okay, so you may pause this video and go over what you see on the screen. I will delete it now, or I will clear it so that I can work with letter B. Please take note of the value 351 351,232 joule. Okay, so let me clear this first, then we proceed to letter B. So point B, I'll go back. Point B is 50. So we place 50 meters, right? So we place 50 meters. Now, how do we calculate for PE? mgh. So again, that is mass, which is 512 times the gravity times the height, that is 50 meters. 50 meters, right? Times the height, and that is 50 meters, which is equal to, please try to use a calculator. I did my calculation in advance, okay? So if you're able to get also same with me here, then you're correct. Then after which, what is the kinetic energy? That's the kinetic energy on the next column. But prior to that, let's take a look, or let's manipulate E total. E total is equal to KE plus PE. On point A, our E total is 351,232 joules is equal to, there is no kinetic energy here, plus we have our PE is 250,880 joules. So we transpose, we calculate for the kinetic energy. Okay? So the kinetic energy here is equal to 100,352 joules. Okay, now, how do we get the velocity? Square root of 2ke over m. So we have square root of 2 times our ke is 100,000, okay, 352 joules divided by the mass, and that is, we have 512 kilogram. Our velocity here, I calculated it again in advance, is equal to 19.80 meter per second. So when you're done, we will use this value to calculate the momentum, as momentum states that mass is the product of mass and velocity. Our mass is 512, right? 512 times the velocity. Okay, times the velocity. We have, sorry, there was a call. 512, oops, 512 kilogram times 19.80 meter per second. So the value is 10,137.6 kilogram meter per second. Okay, so that's it. For the remaining points, you are tasked to finish that. And then, when you're done, study the values presented in the table and answer the process questions. Okay? I hope that this video can guide you in accomplishing scaffold number 3.